Okay, this is our final video for section 3.2, and as I said in the last video, in this one we're going to take a look at integrating products of powers of tangent and secant. And as you may have guessed, what we're going to do here is going to look very, very much like what we did with the sines and the cosines. In fact, there's even similar methods for using products of cosecant and cotangent as well. And the reason why is because of the different identities, right? So we know that sine squared plus cosine squared equals 1, and you can manipulate that to get this other identity right here, which is just a manipulation of the Pythagorean identity. That comes from sine squared x plus cosine squared x equals 1. It comes from that just by dividing everything by cosine squared. You divide everything by cosine squared, you get this different boxed version, and we could do something similar to get an identity that involves cosecant squared and cotangent squared, but we're not going to get into that. What we do need to try to remember, though, is, do you remember from calculus 1, what these two integrals are equal to here? What's the integral of secant squared dx, and what's the integral of secant x tangent x dx? Go ahead and write those in. And you should remember that the integral of secant squared x is equal to tangent x. And then the integral of secant x tan x is secant x. Okay? So what happens? Well, when we're dealing with these sorts of examples, we need to basically decide what it is that we're going to peel off. And you basically need to look at the powers of your secant and your tangent. So if your power n is odd, and that comes from this format here. So if n is odd, then that means we're saying if secant has an odd power, because n has to do with secant, or versus if m is odd, and m has to do with tangent. So if tangent has an odd power, then we're going to peel off accordingly. So looking at example 4, which case is it? Do we have that the power on secant is even, or do we have the case that the power on tangent is odd? So go ahead and answer that question. Okay, so everybody should have hopefully picked that we're dealing with case 2 here, because we have a fifth power on tangent, so tangent is odd, which means we need to peel off a factor of secant x tangent x. So let's go ahead and rewrite this integral. We take our original integral, and we peel off a factor of secant tangent. That means we're going to take one away from each of these. So if we take one away from the secant, that's going to leave a power of 8 on our secant. And if we take one away from the tangent, that's going to leave a power of 4. And then we can write the part that we peeled off. So that leaves an extra factor of secant x tangent x dx. All right, and so since we have this extra power, or this extra part here of secant x tangent x, that's going to essentially be our du, which means that u, as it says here in case 2, u is secant x. So we want to let u be secant x, which means du is going to be secant x tangent x dx. As we already said, that's our du. And since u is secant x, that means everything in the rest of our integral needs to be in terms of secant x, right? So we're going to need to go ahead and rewrite tangent of 4th. Oh, and I see I left an x out there. There should be an x here after the that goes along with the tangent. We need to go ahead and rewrite that. So let's go ahead and think about what that would be. What would the tangent of x to the 4th power be? Well, we know from this identity that tangent squared is equal to secant squared minus 1. So this tangent of x to the 4th power is essentially going to be secant squared minus 1 squared. All right, so let's go ahead and rewrite our integral then. So this is going to be the integral of secant of x to the 8th power times what we just determined was secant squared minus 1 squared. And then, of course, we have our secant x tangent x dx. And that's the hardest part. The rest of it is just completing our u substitution, right? So if we go ahead and now make our u substitution, again, u is equal to secant x, so this is going to be the integral of u to the 8th power. And then we have, instead of secant squared minus 1, we have u squared minus 1. And then again, remember, the secant x tangent x dx, that's going to be du. Again, if you're not comfortable writing that out, you can always go through that extra step of writing it as secant x tangent x, and then dx being equal to du over secant x tangent x, and then those cancel, leaving just du. I'm not going to write all that out because hopefully you can get to the point where you can just see that shortcut. And so because those cancel, because secant x tangent x dx, we see it right here, secant x tangent x dx, that's du. And we can't quite integrate because we have this product going on. Oh, I also see I left off the squared. You can't forget that. We have this product. We have u to the 8th times u squared minus 1 squared. We can't use the power rule on this because of the parentheses, because of the squared. We need a bit of algebra. So we're going to go ahead and do that. We have u to the 8th. If we square this u squared minus 1, that's going to give us u to the 4th minus 2u squared plus 1 du. And then we can go ahead and distribute now the u to the 8th. So this is going to be u to the 12th minus 2u to the 10th power plus u to the 8th power du. And now we can take the antiderivative. So we have 1/13 u to the 13th minus 2/11 u to the 11th power plus 1/9 u to the 9th power plus c. And then back substituting, we have 1/13 times what u was, that was secant x to the 13th power, minus 2/11 times secant x to the 11th power, plus 1/9 times secant x to the 9th power, plus c. And that's how you perform a integral on products of secant and tangent. Example 5 goes over the other case. It goes over case 1. I'm going to let you go ahead and read. I'll post the solution for example 5 in the lecture, and I will also post the solutions for the extra practice problems here so you can take a look at those. But that's going to do it with the video portion of your lecture for section 3.2. Thank you.